Assalamu alaikum, or talo falava, kia ora, hello. I thought I'd try out a few greetings today. So we're looking today at the analysis of part of the time series investigation. And this time, the last part we're going to look at is forecasting. And you'll remember that forecasting is probably one of the most important parts of this particular thing because it's our reason for doing a time series. Usually we investigate a time series graph because we are looking at using it to find out what's going to happen next, and we use particular values that are the past, so we use our history to look into the future. So let's have a look at what's going on. Okay, so this graph, the forecasting graph, comes from this part, and again I will show you how to get there. So in the graphing function, NZ grapher, we go back to the time series, we drop down, and it's the last one of our four graphs here. We wait for it to load, and there it is. Now, it looks very, very similar to the first part of our residual graph, but it's got this red part on the end. So we've extended past the values that we knew into the values that we don't know. And those are the red values that we're actually interested in. And what it's actually saying is that it's giving me a prediction, that bold red part, but we can't tell what's going to happen in the future. So it's giving me an error rating around it. That's that light pink part. And the saying goes that the closer those pink parts are to the tight red part, the better off your prediction, the accuracy of your prediction will be. So let's just go back here. All right. So pushing that and copying it in, no problems with that part. So copy and paste it into your assignment, and then you need to look at how wide the pink area is vertically, so straight up and down from the line, all right? Not how wide it is this way, but how wide it is vertically from the trend line. This tells you the confidence level of the prediction. If it's really tight around that red line, then you know that it's going to be pretty accurate. You should talk about it in respect to the Holt-Winters model, because that's what's been used here to make this particular one. So we should say the Holt-Winters model shows us this. You can also use the green line going backwards to make predictions about the past and talk about how well those past predictions would fit the data. So if your past predictions are fitting really well, that means that you have a good idea that your new ones will too. And this is part of the appropriateness of the model that you need to do. So I don't know how I flipped that far. So this is hit here, all right? So you can see that in these values here, they're very, very tight. It's at the top and the bottom that there's some loss of confidence. We're not sure how far down they'll go and how far up they go, but the middle part of it is very tight. We're talking about this depth here. So this width here for this point would be down to here and up to here. All right, so the historic predictions, that's the green ones going backwards, of the Holt-Winters model appear to be closely in line with the raw data, the black line, right? Historic predictions, black line. Also, the prediction interval is quite tightly fitting around the prediction line. This means we can have high confidence that our predictions will be a fairly good indication of the next couple of years. As we get further away from the most recent data, we find that our predictions are less reliable, and therefore our pink area will actually increase. All right. So the next thing we want to do is actually get values that we can put into our investigation. And to do this, we go back to our graph and we push this little button here. All right. So let's do it. And that will give us this picture here. All right. And we want to actually cut and paste this into our investigation. So let's just have a look. We go to here. We press the forecast output. Gives us a table like this, right? This table is actually bigger than my screen. So what I can do here is I can turn this bottom bit off, hide the bottom section. Now I can see pretty much the whole graph if I'm really careful. All right, and I want to cut and paste that, so if I can get rid of the top part as well. I don't know if I can. But can I hide the bookmarks? No. Anyway, what you're going to do is cut and paste this into your actual assessment. So to do that, if you right click on it, you can save as, all right, and print it in that way. But the easiest way to do it is to use your cut and paste tool again and cut it in from this way. So I haven't got the top of it, but that's right. That gives you the example of what I'm doing. So depending on how much data is there, it depends on what you're looking at. But we're only interested in the very top part, probably, because we don't want to make predictions too far into the future anyway. So I probably could have stopped that at about, I don't know, July of 2023. All right, back to the original one. So you can see here, so this little button up here, you can get rid of that part there and cut and paste it in. Okay. Once you've got it, you want the time, the minutes, prediction. So you get 3 values. This one here is the red, the dark red line on your graph, and this is the light pink one. What's between there is shaded light pink. Okay. So it's given you an interval, like a confidence interval. So using this model, I'd expect that the Arctic ice in July of 2020, so you look for July of 2020, to be around, not perfect, around 7.9339 million square kilometres. But as I can't be certain what it's going to be, because you can't be certain about any predictions, I'll predict that it'll be between 6.9 and don't forget your units when you're doing this. So 6.9684 and 9.0328. And then I'm done both Julys so that I can see what's happening from July to July, because I've got that seasonal effect. Can't do a lot of comparisons if I pick July and then August of the next year, or July and February of the next year. So it's quite a good idea to pick the same month. So in July of 2021, so going down to July of 2021, I would expect there'd be 8.113, and I can't be sure again, so I'm going to be between this number and this number. And you can see that that width is a lot bigger. This shows that there is an increase in sea ice for the month of July from 7.933 to 8.1153 in my predictions. So I'm predicting that it's still going to be increasing. But is it increasing by a lot? Well, I could compare that to that average I found in my first long-term trend and see if that's what's expected for it to increase by. Okay, so that's also a good thing you can do. The last paragraph of this confidence part, before you write your conclusion, should be saying that you don't have complete confidence in your predictions. So we can't be completely confident because there are other things that can happen that can influence it. So we've got all those things that happen in the world, like the global financial crisis, COVID, SARS, earthquakes, anything like that that could actually impact our predictions in the future. But all things being equal, we can't be completely certain about our predictions, as there are a number of factors that could be affecting the amount of sea ice. One of these factors is possibly, and you do some research about it, so you find out that there is huge incentives in global warming, and they're trying to do this, and that could possibly have a huge effect on the amount of sea ice and how fast it's degrading. So furthermore, the model used to make the predictions does not fit very well with this data, and so the predictions cannot be considered to be very reliable. You can write that if it's applicable, but actually mine fitted really well, so I wouldn't write that part. I'm pretty happy with how much I've predicted from my graph. Okay, so your turn to have a look at it. Remember, 2 predictions. You actually only need 1 to pass, but it's a good idea to do 2 because you can compare those 2 in that way.